language and other cognitive systems. So this talk is going to focus on that, the relationships between them, and the overarching conception involved with this is that we have one's cognition. In effect, it's a challenge to the previous model of Fodor and Chomsky, which was that there are watertight compartments called modules. And so, for example, there's the language organ, which is a autonomous module in cognition, which just does language. And it seems to me that very little in cognition, indeed, is independent. I suspect that there's a large amount of interaction and overlap. And in particular, there's a large amount of structural similarity across them. So my whole object is what I call the overlapping systems model of cognitive organization. It's to identify a set of large-scale, roughly distinct cognitive systems that we have, and then see how what kinds of major structural properties they have in common. And in fact, the finding is, so let me just list a few of the major cognitive systems that I think are roughly there. Again, it's roughly, and I call them systems instead of modules in order to choose a different word than the one that suggests total autonomy. So I use the word systems for these. And they would include language, the language system, with a much fuzzier boundary than the language module of Fodor. It would include perception, either as a whole or in its various modalities, so in particular visual perception, auditory perception, kinesthetic perception, feeling, and so forth. It would include motor control as a system. And I propose that there is also an affect system for emotions and feelings. There is what I suspect is a culture system, a part of the brain dedicated to structuring our cultural patterns. There would be what I propose as an understanding or reasoning cognitive system. And so by the overlapping systems model, the concept is that each one of these approximate large-scale cognitive systems might have a few organizing characteristics that are uniquely its own. There will be other organizing characteristics, structuring characteristics, properties that are shared across several of these cognitive systems. And there will be some which are so general and so fundamental that they run across all the different cognitive systems. Just an immediate example of that would be hierarchical embedding. So one thing embedded within another, I think is something that runs across, we can find in virtually every, as a structuring phenomenon in virtually every cognitive system. So I've just listed some of what I think are the main substantive cognitive systems, and then I listed second there, I guess it's in 1.2, what are some of the structural features, I'm going to call them organizing factors, that run through some or all of these different cognitive systems. They run through language, they run through different modalities within perception, they run through motor control, and so forth. And there is some number of them. I'm only going to mention a few, but you can look at it at your leisure. Among the main ones, the first one would simply be schematic structure, some kind of abstractive delineations that exist within any given cognitive system. So language certainly has a schematic system. It's in fact embodied by the closed class forms, which I'll describe in a second. In visual perception, there's schematic structuring in terms of the delineations that you see, for example, in dividing a room into its parts and so forth. In motor control, it would be the distinct movements that you can make as delineated, distinguished from each other. Another organizing factor would be the temporal structure of something. And this, again, cuts across all the different cognitive systems, and it would include things like phase, so the start or stop or continuation or absence of some process going on in one or another of these cognitive systems. It would include things like speeding up and slowing down, or coming to a stop, or starting up. It would include coordination of such things like alternating things, or coordinating processes across systems. It would include things like putting something on hold until some trigger starts it up again. All of these would be aspects of temporal structure that presumably runs through all of the different cognitive systems. A third organizing feature would be causality. So any way in which some phenomenon or process within any of the systems causes another one, or is caused by something outside itself, these would all be part of that. And then to switch, just to stop at those three there, and then to switch to the cognizing factors, we've got attentional structure. So within every system, cognitive system, you can direct different patterns of attention over the phenomena. You can direct different patterns of attention over what you see, over if you're moving different parts of your movement, over different parts of what you're saying. So this is all the attentional system. There's the perspectival system, or perspectival organizing factor, which is something like which perspective point you're looking at the system, the other elements of the system from. There's the memory system, so there's working memory, which elements of a current system can be easily held in working memory, which ones cannot, which ones can be readily maintained in long-term memory, and so forth. Or the difference between familiarity and novelty is built on whether you remember it or not, and that distinction can probably show up in any of the cognitive systems. So this gives you an idea of what I mean by the distinction between the substantive cognitive systems, things like the language system, perception, motor control, affect or emotion, the understanding system. Those are the substantive cognitive systems. And these organizing factors, these are the structural aspects that either show up just in one of them, one of the substantive systems, or across several, or running all across all of them. So that's the rough idea of how I'm seeing this, and so I call it the overlapping systems model of cognitive organization. And it's as I say, it's in direct challenge to the Fodorian notion of autonomous modules. So so if we've got comparable structural features, factors, organizing factors across different cognitive systems, what are the ways in which that could happen? So I can picture three main ways that you can have this kind of commonality of structuring of organization, and they all have implications for evolution. Maybe I can, if I try and draw something on the board, I'll leave the microphone, so maybe I'll try and draw it in the air. So one way, and the evolutionary idea is that some cognitive systems are more ancient than others. So for example, vision and motor control were in place in our cognitive organization much longer than then what in humans is the last two cognitive systems to have evolved, namely language and culture. And again, I propose that there's a cognitive system, substantive system, dedicated to acquiring and manifesting cultural patterns. You see it to some degree in chimpanzees. It's known that now that there are cultural differences across different chimpanzee groups, but it's really elaborated in humans. So, so since those are the last two to have evolved, how is it that they could have certain commonalities of structuring with previously existing? So here's how that might go about. Let's say this is the circle, large circle is the totality of one's cognition. So let's say that there is some structuring factor. So one way that you can have commonality is that there is some independent, separate neural system that is responsible for a certain kind of structuring. So let's say, just to pick one out of that list I gave, let's say hierarchical embedding, the capacity to embed or nest hierarchically. Well, let's say within this total circle, there's some separate neural system whose function is to enable hierarchical embedding, one thing inside of another, inside of another. Well, if several cognitive systems exhibit that, so here's vision, here's the visual substantive system, it would have to establish neural connections to that organizational factor, neural system, in order to manifest hierarchical embedding within vision. The same would happen with this motor control over here. It would have to establish connections to that. And then let's say language evolves last. So let's say there's a language system here. Then if it exhibits hierarchical embedding, which it does, then presumably by this account, it would have to develop connections to this little neural system that handles hierarchical embedding. Okay, there's another way that you can account for commonality of structural organization. And that is, let's say, namely that it's located at the outset within a single substantive cognitive system. So let's say the structural capacity to embed hierarchically first evolved in visual perception, just to pick something. So then here's all of cognition, here's the visual system, and within the visual system, long ago evolved, there is a portion of that system, a neural subsystem, which is responsible for hierarchical embedding. Well, if language evolves later, so in other words, there is in the brain somewhere, it happens to be located within the visual system, let's say, the brain now has a system which is capable of orchestrating hierarchical embedding. Well, if language then comes along later and evolves as a new, approximately distinct cognitive system, it might develop connections to that subsystem already within vision. So in this respect, the evolution of language depends on tapping into, making connections with a subsystem already present, long since evolved, as part of some already existing cognitive system, let's say visual perception. Okay, that's the second model. The third possibility that accounts for common structure is that there are each separate cognitive system, like vision and motor control and language, has its own copy of this subsystem. So language has a little subsystem for multiple embedding. So does vision have one, and motor control has another one. So then the question is, how did those separate copies arise? Well, there's several evolutionary accounts. One is that it apparently often happens that a previous structure can, through some mutation, get copied. A copy of it is simply produced. At first it's a mistake, but once it's there, it can be utilized. I mean, the notion might be just a gross physical example. That some people are born with a sixth finger as a mutation. Well, in time, if that doesn't hurt anything, it might stay in place and get used as a specialized, as another copy. Well, so that's one way that, let's say, vision already had a subsystem for embedding, multiple embedding. So as maybe some neural tissue copy by mutation was made over here, and then let's say some language system evolved around that and included it automatically. That's one way. Another way is convergent evolution. It could just be that certain structuring characteristics are fall out so readily, can evolve so readily that they independently evolve in each of the three systems, or each of the many cognitive systems. And a fourth possibility is, the third one is just pure accident, coincidence. So anyway, these are the three main models by which you can account for commonality of structuring across different cognitive systems and their evolutionary implications. So if you look over the various cognitive systems, the substantive cognitive systems, language has, and look at their structural characteristics, it turns out that language has, it seems, is certain possibly unique ones, or most, is the most elaborated in language, which in itself has to be accounted for. And in fact, my last talk will address this directly. The last talk is on the evolution of language. One of the rarer or unique properties, structural properties of language, is that it has two co-systems that are integrated with or correlated with each other. One is it's essentially the basic Saussure type of observation about language. There is a linkage between meaning and form. The form meaning association. Standard notion of morphemes. So you have a certain phonological shape like bucket, and associated with that is a certain concept, this object. And so you have, I'm calling this here the relationship between two co-systems, the expression co-system, which means how the overt form that you use, and the conceptual co-system, which is correlated with it, which is the concept that is associated with it. Now, you look around various other cognitive systems in, let's say, vision, and you're hard put to see anything comparable in that. I mean, is there a difference between an expression co-system and a conceptual co-system? It doesn't make sense. What about motor control? Similarly, it doesn't quite fit. So, maybe language, or any kind of communication system, it could be some kind of gestural system as well, is perhaps unique in having that kind of correlation. In addition, within the expressional system of any communication type system like language, it has two subsystems. Language has two subsystems, namely what I'm calling the open class subsystem and the closed class subsystem. And again, this is what I can address more. In a second, I'll summarize this. In a second, I will expand a little further on what I mean by open versus closed class. But first, there's the issue of how can we undertake this comparison across cognitive systems? Let's say between language and something else. How is it even possible to do so? We have to have some points of of correspondence to do so, and it is in fact a problem. For example, if the whole point of my comparison is to compare what is structural, what is organizational across different cognitive systems, but how do we know what is organizational and structural? So within language, luckily, as I'll expand on in a second, the closed class system, which is overtly detectable, you can discern the closed class system of language, is a subsystem of language which is dedicated to conceptual structure. The open class system is dedicated to conceptual content. The closed class system is dedicated to conceptual structure. So there is a division of labor, a fundamental division of labor between content and structure. To use an English idiom, language as a cognitive system hands you structure on a silver platter. It has an overt, distinct system, easily identifiable, well, fairly easily identifiable, which is dedicated to representing conceptual structure. Possibly no other cognitive system has this. So for example, within vision, visual perception, most of what perception psychologists deal with, they would probably say is structural within visual perception. But there's no, first of all, there's no determinative way for them to say that this is structural and that's not. So for example, you can ask of a perception psychologist, is color structural? I mean, a perception psychologist might easily say, well, the perceived delineations, outlines of things are structural. But then you can ask the psychologist, what about color? Is color structural? They would have no principled way to answer that. Unlike in language, you do. You have a principled way to answer, is X structural? Well, you can just say, well, is it expressed by a closed class form? If it is, it's structural. If it isn't, it's not. I mean, that's not the end of the story. That's too simple. But at least it's a first kind of distinction you can make. There's nothing like that in vision. Similarly, another problem is within vision, visual perception, there's no principled way to say at what stage of visual processing a structure appears. In fact, it seems to appear all the way, so from the retina, all the way back into the optical cortex and all the successive processing that goes on. At each stage, something structural takes place in this processing, but no single stage seems to be privileged to be called the structuring subsystem of visual processing. So, whereas in language, nothing like that occurs. You have a given closed class system, which is its own stage. It's a single stage. There's no issue. So there are real problems in trying to even open the question of how to compare structure across cognitive systems. My methodology is to say, well, since the nature of structure as such is given most explicitly, most definitively by language, language is a good cognitive system to start such an investigation from. So you can go look at language first, start with language, see what kind of aspects of processing are structural in character, and see if something like that corresponds in other cognitive systems or doesn't correspond. So that's my methodology for carrying on this cross-system comparison within cognition. Okay, now just I'm going to switch to section 2. This was the content of my first talk, and I don't want to repeat the whole thing because a number of people are here who heard my first talk. But just to summarize it quickly, by definition, to define them quickly, closed class forms in any language are those classes which have a large number of members, and you can add many members very easily. So, for example, nouns in English, simplex nouns in English, we have hundreds of them, maybe thousands, I don't know. And it's very easy to add new nouns in one day. And you just learn a bunch of new nouns. Same with verbs, same with adjectives. But everything else is closed class. For example, and closed class forms come in, they can be bound, such as inflections or derivations and so forth. Or they can be free forms, like prepositions, so like or classifiers or conjunctions. So for example, English has several dozen prepositions, like in, on, around, above, below, through, and so forth. And but it only has several dozen. It doesn't have hundreds. And it's really hard to add a new preposition. You can't just go to a class and learn 10 new prepositions and go away using them. So closed classes are ones which have relatively few members, and it's very hard to add new ones. And the rest I'll leave off. I'll just say that the open class forms in any given sentence or portion of discourse, they contribute the majority of the conceptual content of that sentence that's expressed by that sentence, whereas the closed class forms express the majority of its conceptual structure. So there's this content structure distinction. And since my whole issue here is this whole comparison is over structure, not over content. Structure is the organizational features of these different systems. I'm automatically going to stick within language just to the closed class forms. So that's all I'll stick with here in all these comparisons. So that's my summary for section 2, and we can go on to section 3. 124, page 124. What I'm going to do is run a set of comparisons between language and one other cognitive system. So in 3, I'm going to compare language with visual perception, compared and contrasted, and we'll find that it's partially overlapping. It's one of these partial overlaps. Some things it has, some things vision has, only vision has that are absent from language. Next, we can look at structuring properties that language has that are absent from vision. And then we can look at things that are in fact in common, which are, in the case of language and vision, quite extensive, and which I think attests to the fact that, or to the theory that, as language evolved, it borrowed, in fact, I suspect that language borrowed most from vision, from visual perception, kinesthetic perception, and from the reasoning or understanding system. It borrowed very little from other cognitive systems, like affect or the culture system. So in fact, after we get through with this language-vision comparison, we'll go on to the comparison between the structuring systems of language and the affect system, then to language and the culture system, and then between language and the understanding system. And we'll see that there's a difference in how much there is overlap, how much overlap there is. So first then, between language and vision, and let's first look at cases of non-overlap. Aspects of structuring that vision has that are pretty minimal in language structure. So here's a list of 5, and I'll go first with the first one is bilateral symmetry. it appears that, I mean, I understand from perception psychologists that a strong aspect of structuring within vision is bilateral symmetry, seeing that the two halves of something are reflections of each other, for example. Like, for example, humans down a midline axis, sort of reflections of each other's bilateral symmetry. It's not clear to me why that's so important, but I understand that it is. Well, the language has very little in its closed class forms that express bilateral symmetry. The closest I can get is maybe each other, which is a closed class form. It's a free, in English at least, it's a free form. It's a closed class. And for example, let's say you say they kissed each other. Well, maybe you can imagine an image of paired faces with lips meeting and so forth, sort of some kind of bilateral symmetry. And maybe one other example, in classical Greek, there are two closed class particles, which are men and de, which mean on the one hand, on the other hand, but they're closed class particles, so we know that the language is treating them as closed, as part of the closed class structural system. Maybe that's an example. It's kind of balance, even balance kind of thing is another example. But beyond that, it's pretty minimal. So let's try another one. Vision also has what I suspect is a elaborate system for scene parsing, for parsing out kinds of rotation, whereas language is absolutely minimal with respect to that in its closed class system. So English and its closed class system has, for example, only two distinctions, over and around. These are closed class prepositioning things. I call them satellites. So, and they distinguish the orientation of the spin axis of something that's rotating. So, for example, around is where the spin axis is vertical. So this is around. So you can say, I turned the pail around. You're turning the pail this way. Over is where the spin axis is horizontal. So I turn the pail over, you take the pail and you go like that. So English has this distinction, but that's all. Just that distinction. Everything else is absent. So now let's see what could be distinguished visually. And by the way, for those who were there for my sign language talk, sign language also distinguishes many of these distinctions because sign language in general is closer to the fine-grained character of visual parsing. So, for example, vision and in fact sign language will distinguish different degrees of a circuit around something. In fact, what I'm going to show is in fact the way you would do it in American Sign Language. So if you say, I ran around the house for 20 seconds, you go like that. I ran around the house in 1 minute, with a sharp thing. I ran around the house in 1 minute. I ran around the house for a few minutes. I ran around the house for hours. And all that you both sign and can see, visual perception. But in English, all you've got is around, 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 around. The word around doesn't change. There are no distinctions, further distinctions marked. Similarly, you can visually distinguish different geometric arrangements with rotation. So, for example, the spin axis can be at the center of the object, so like a rotating CD disc, or a pencil spinning on its axis, or a propeller spinning around. These are all different geometric things, which you can easily see. None of it is distinguished in the closed class forms of language. Again, English is just around, around. The propeller spun around. I spun the pen around and so on. Similarly, it would be distinct if the spin axis is at the edge of the object. For example, if you're shutting a door, you're at the edge of a door, the door goes like that. Or if you're swinging your cape, a planar thing like that, you're holding it at the edge. All of these is around, swung the cape around. Visually, you'll know all these geometric distinctions. Linguistically, they're bypassed in the closed class system. And finally, where the spin, the axis of spin is outside the object itself. So, for example, the Earth revolving around the sun, or a hoop, which is spinning. Again, the Earth revolves around the sun. The hoop spins around. It's still around, but visually you'll see a difference. Conceptually, you'll see a difference. And finally, whether there's consistency in the rotation. So if you've got a hanging rope and it's spinning around, if it all spins uniformly, you say it's spinning around. If it's stuck to the ground and this keeps spinning, then you'll say it twists around. So it's not uniform, but it's still around. Yet visually, you're going to parse that differently into different kinds of structure. So here again is a case where vision has a much finer-grained kind of structuring system for the domain of rotation, let's say, than language does. And again, when I say than language, I always refer to what the closed class system does. The open class system can indicate many more things, such as the word twist, which automatically refers to this non-uniform kind of turning. But the open class form of language, the open class subsystem of language, I suspect, is more correlated with other cognitive systems, with say the distinctions available through visual and kinesthetic and motor control and perception, whereas the closed class subsystem of language is much more restricted. So another comparison between vision and language is similarly the distribution. Vision has a much more extensive structuring system for the patterns of distribution. So if you look at foam on a beer foam, you look at the folds in a robe or in a curtain. You can look at in a piece of wood. You can look at the grain of the wood. You can see many kinds of patterns of distribution, and vision is supreme at that kind of structural delineation, patterns of distribution. Whereas in the closed class system of language is absolutely minimal. So, for example, all that we have in English is, and I'll just pick the case where it's static. You have either it's neutral to whether it's discussing distribution, or it shows scant distribution, or dense, sparse distribution, or dense distribution. So, for example, we have distinctions like there are peas on the knife. There's a knife with some peas on it. There are peas on the table. There are peas in the jelly, in the jelly also, in Jello. So that's saying that's neutral to whether they're dispersed or not. It doesn't indicate it. Then you've got forms which indicate sparse dispersion. So, for example, there are peas here and there on the knife. There are peas here and there on the table. There are peas here and there in the gelatin. And then you've got closed class forms that indicate dense distribution. So there are peas all along the knife. There are peas all over the table. There are P's throughout the Jello. The Jello throughout. Throughout is specifically three-dimensional. So it distinguishes 1, 2, and 3-dimensional. It distinguishes sparse from dense distribution. It distinguishes between presence of distribution versus neutrality to it. It also, as it happens, distinguishes between stationary, and moving. But that's all. That's it. That's the extent of it. Vision distinguishes much more than that. So, for example, nowhere in the linguistic distinctions made by closed class forms is there anything about whether let's say the P's all over the table, are they evenly distributed or unevenly distributed? Nothing in language, closed class forms tells you that. We'll make that distinction. But if you look, you'll instantly know if it's even or uneven. Are there clumps of P's on the table with whether it's even or uneven? It doesn't matter. You could also have clumps. It doesn't matter. If you say there are P's all over the table, it won't tell you. Are the P's completely dense, leaving no space between them, or are they spaced with some intervals between them? Nothing in your in English all over will tell you that. But again, visually you can tell instantly. If it's not P's but spaghetti noodles, are they arrayed evenly, or are they crisscrossing, or are they scattered? Nothing in all over will tell you that, but visually you'll instantly know. So these are ways that visual parsing. Parsing in this case means determining the structure of what you're looking at. Gives you much finer kinds of information than language, which is relatively minimal. Okay, so if we draw two circles of what's overlapping, we've been looking at the things that are in vision, but either absent from language or minimal. Now let's do the complementary thing. Let's look at things which are big in language and minimal in vision or absent from vision. Okay, so that's the next section. And the first thing that's big in language is, what's the first one? Is not legality, but reality status. So languages have all sorts of forms like negative, potential, conditional, counterfactual, and indicative, factual, which in fact probably every language has closed class forms that indicate distinctions like these, maybe not all of them by closed class forms, but at least some of these are going to be by closed class forms, and hence are structural in character. But nothing in a visual scene nothing in your visual perception marks these distinctions. What you look at is simply there. There's nothing within visual perception which even recognizes this category of distinctions. The concept of it's not being there, or the concept of it's being potentially there, or conditional on something else, or in fact it wouldn't be there, nothing. It's just there. So this whole category of structural distinction is present in language, absent in vision. The same can be said for modality, or mood, which modality. The modals in language, a lot of languages have modals as closed class forms, not all do, but English has a closed class system of modals, which are things like can, should, must, need, dare, and so forth. And boy, this is a sensitive microphone. These modals represent forces that act towards or against the occurrence of some event. For example, he should lock the doors when he leaves. There's somebody tries to exert pressure on someone else to perform a certain action. Or the pear must be ripe by now. There's some kind of notion of, epistemic notion of whether your inferencing system is constrained to come to just one conclusion. But nothing of the sort takes place in vision. Again, what you're looking at is simply what has occurred. It is there. There's nothing within the visual processing, the parsing of the visual scene, the perception of the scene, which indicates something that has caused it, or made it inevitable, or made it impossible, or something like that. It's just there. Okay, a third structural thing within language is in addressee's inferred knowledge status. In other words, the speaker infers something about the knowledge status of the hearer that he's talking to. That's my term for it. The conventional term for it is definiteness, because I think that's what definite is. So, for example, if I say, the difference in English, if I say I fed the cat, if I say to you I fed the cat versus I fed a cat, if I say to you I fed the cat, it means I infer that you can readily identify the particular cat I'm talking about, the particular referent of the noun. But if I say to you I fed a cat, it means I infer that you can't readily infer the particular identity of the object, that you in fact don't know what it is, which one it is. So that's another structural feature of language, but again is essentially absent in visual parsing. Very little or minimal, very little of what you look at, when you look at something, very little of your visual perception is involved with whether or not somebody else can identify the object as well. Okay, finally, there's the reality status of the speaker. And there's a conventional term for that in linguistics. It's evidentials. And there are some languages are enormously rich in evidential distinctions, including the language that I worked on, an American Indian language, Atsugewi, which marks a certain number of distinctions. And languages like this, with inflections on the verb, will mark distinctions like whether you, for example, if you put on a certain one inflection, it means I tell you it as a fact, like John is chopping wood in the forest. I know it because I saw it. You put on a different inflection, and it means I infer it through non-visual sensory input. For example, if you say, John must be chopping wood, and you put on this suffix, the idea is that it's because you can hear the sounds of the axe chops coming out of the wood, so you infer that he's chopping wood. If you put on the one which is based on evidentiary evidence, you put on that suffix and you say John must be chopping wood, it's because, for example, you look where the axe usually hangs on the wall and it's not there, so you can say, John must be chopping wood. You have to put on a third suffix, different one. And one more, let's say John usually chops wood at 3 o'clock in the afternoon. It's 3 o'clock, so you say, John must be chopping wood. That's a fourth different distinct suffix based on temporal periodicity. All of these distinctions are made, and they refer to the speaker's knowledge status. None of that appears in visual perception. Again, what you see is what you get. That's an English expression. What you see is what's there, and there's no question about whether or not you're inferring it, or you're deducing it, or you're simply take it for granted. It's just, well, it's just assumed to be actual. And in this case, we can bring in a third kind of cognitive system, just briefly bring in the understanding system or reasoning system. It seems to me that this kind of knowledge status kind of thing, especially this last one of evidentials, is very similar to this another of the cognitive systems, the reasoning or understanding system. So if it is, then it turns out that if you draw circles, here's a circle for visual perception. It doesn't have this particular phenomenon of knowledge status, let's say. Crisscrossing it is a circle for language, partially intersecting it. And language does have it, but it has it over here. It doesn't have it within the part that intersects the circle, because it's not in vision. But yes, intersecting it is the inferencing, the reasoning, understanding system. It shows up in there as well as in language. So you can start drawing certain kinds of Venn diagrams with partial overlaps to show that when some structuring feature is common to a couple of cognitive systems, but not to others. So that's the general case. This is an instance, therefore, where something, namely knowledge status, shows up across the understanding system and the language system, but doesn't show up in the vision. Okay, so now these were cases where we found things, structural features that were in language but not in vision, or in vision but not in language. Now we can look at the overlap, where in fact the structural phenomena is in fact common to both of the systems. And it turns out this is really expensive. And I suspect that language, when it evolved, borrowed perhaps the most from the visual perception system. The first thing that might be in common would be configurational structure. So language often has a lot of closed class forms. A lot of languages do, not all languages, for representing path configurations of the path that something takes in moving. So, or the site that it occupies, a kind of geometric delineation. So, for example, in is in English such as there is water in the vase, there is a radio in the dumpster. It involves the concept of two objects related to each other spatially in a certain way. What I call the ground object consists of a plane so curved as to constitute a volume of space, and the other object, the figure object, located at some point or points of that volume of space. So you can say, therefore, that the radio is in the dumpster. I suspect that something like that is visually perceivable. There's a general perception of inclusion or surrounding that might be perceived in a way that's quite comparable to what the preposition in means in English. The same for maybe along, like the ball rolled along the ledge, or the hunter walked along the trail. It's the notion of a moving path, a moving point describing a path which is parallel and alongside another linear path. Okay, well, that is perhaps also readily perceived as something. It's just a guess. I mean, a lot of what I propose as for other cognitive systems is offered as a suggestion for further research among the specialists in those fields, in this case, perception psychologists. So I suspect that some of the geometric delineations that show up in language preposition-type forms might well be perceived as such visually. A second kind of overlap is structure within bulk, so within a volume. And again, this shows up in linguistic spatial forms. For example, take the word along. We just saw along. Along doesn't care about the bulk of the second object, of the ground object. It's neutral to the bulk. So therefore, you can use the same word along if you're talking about a caterpillar crawling up a thread, or here's a tree trunk, a caterpillar crawling up a tree trunk. It doesn't care. It's still along. It's along. All that along cares about is that this ground object can be idealized or boiled down to a linear abstraction. And again, I suspect that visual perception may well have a similar kind of bulk abstraction. Something you might well perceive the same two events as similar. Even, in other words, chimpanzees without language might well perceive something in common across those two spatial relationships. And this correlates with something that Marr, who's he's a late perception psychologist, described as axes of elongation. He thought that as you look, for example, at a body form, you might well perceive in a subliminal way, my term for it is you might sense it within it, certain axes of elongation, sort of like a stick figure drawing. And in fact, I'm especially impressed by the fact that children very early can draw what's called in English stick figures. So they go through a progression. So the earliest form of a stick figure of a human, at least in America, is typically something like a circle with 4 things sticking out of it, and that eventually develops into something like a circle for the head, a line for the body, 2 lines for the arms, 2 lines for the legs. This is cultural. It turns out that Australian Aboriginal children do different sets of abstractions, but which are used by the adults, but they nevertheless set up connections to that. And so the whole closed class subsystem of English, of language for space at least, may well tap into that specific subsystem in vision as it evolved. Let's see what time it is. 11:09. I should start speeding this up. Let me do the third one, which is the topological thing. I also suspect that topology, one thing I mentioned in the first talk was that closed class forms are topological in character. So for example, the word through in English, it doesn't care about the shape of the line. You could say, let's say here are the woods, you could say, I went straight through the woods, or you could say, I zigzagged through the woods, you still say through, or I circled through the woods, you still say through. Through doesn't care about the shape. It abstracts away from Euclidean geometry and just does topological type of geometry. I suspect the same is true for vision, that it may well be that there's an aspect of vision which is topological in character, and so that you might be able to perceive a structural abstraction of inclusion, something inside something else, regardless of many other variables, like whether this is big and this is small, or this is curved or straight, or whatever. You can abstract away. I suspect your visual processing will abstract away a certain schema of inclusion as just as a visual schematic abstraction, in the same way that it is done in the closed class forms of language. So that would be another commonality. I think for the sake of, well, what I do in a number of these next ones is, it's almost a recapitulation of some of the talks I gave earlier, which already showed, I was already in those pointing out similarities, parallels between spoken language structure and other forms of structure, such as visual structure. So let me not do that. Let me just skip to one that I know I didn't present, and that's down to perspective point, where I give this example of lunch. Here's 2 sentences. I think for this I will go to the board. So here's 2 sentences. One is here's a lunchroom. It's a restaurant that you eat lunch in. And here's a door. And the first sentence is the door slowly opened and 2 men walked in. Where are you standing? This is a test of your English. Where are you standing? In the room. In the room, right. And if you say instead, 2 men slowly opened the door and walked, 2 men slowly opened the lunchroom door and walked in. Where are you standing? Outside. That doesn't quite have to be, but that's typical. Okay, so why is that? Well, because of a principle in English, it's a structural principle of closed class forms in English. English has a general principle that if an agent is visible, or the initiator of some action is visible, we must mention it as a subject. So, whereas if it's not visible, you must not mention it as subject. This is a general rule. It's often broken, but it's an approximate rule. For example, if you hold a glass and you do this and it falls to the ground, you cannot say the glass fell. You have to say, I dropped the glass, because you're fully visible. Right. So, similarly, if you say the door slowly opened, the lunchroom door slowly opened, well, how is it possible for the door to slowly open, caused by agents, and you're not mentioning the agents? It's because of a principle, which is that you can't see the agents. Well, how come you can't see the agents? You say, the sentence goes on, the door slowly opened and 2 men walked in. That means this is the direction of motion. They walked in. Therefore, they come first they're outside, then they're inside. Well, there's only one way the door can open. You can't see the agents doing it, and they start outside and inside. And that's if you, the observer, are already inside. There's only one geometric possibility, assuming that the lunchroom walls are opaque, not transparent. And through some lightning calculation of geometry and linguistic principles, if you hear that sentence, you automatically know to place your perspective point inside. But if you have the sentence, 2 men open the lunchroom door, they are mentioned, therefore they must be visible. Therefore, you're probably standing outside watching them do it, and then they walked in. That's fine, they're walking away from you, but that in doesn't tell you if its words are away from the speaker, unlike come and go. So fine, you're outside. Here is therefore an aspect of language that structures one of the great schematic systems that I treated in the first lecture, and that's perspective point, location of perspective point. In the first case, your perspective point is located inside the lunchroom. In the second case, it's located outside the lunchroom. It's ascertained through various structural devices. Well, I suspect that perspective point, location of perspective point, is one of the things that is highly part of visual perception, visual parsing. You automatically know the location of your own perspective point if you're here, or if you're seeing something from over here, or if you're seeing it from over there. You seem able to project your perspective point, like you can pretty much tell what somebody else is seeing from their perspective. So you can project yourself into someone else's perspective and see what's happening. So there's, it seems like this is a good additional example of overlap between language and visual perception in terms of structure. Okay, I think I'll end the comparison between language and vision with this, and then go on to the next comparison between language and, so this will be section 4? 5. Between language and affect. Affect is another system. Means emotions and feelings and so forth, and it would include, anything like anger, liking, hate, fear, all those kinds of things would be part of the presumed affect system, which I suspect our cognition has as a quasi-autonomous system, cognitive system. I mean, separable in some respect from other aspects of cognition. So the question is there anything structural in that also is structural in language, as shown by the closed class forms? And in fact, the finding, rather surprisingly, is that it's quite minimal. Language has very little that's structural with respect to affect. It has sporadic instances of closed class forms around various languages that refer to something affective. For example, it had the diminutives in many languages can represent an affect of affection. The pejoratives in many languages can or do indicate an affect of dislike or disgust. We have desiderative forms in many languages which indicate wanting, optatives for hope. We have forms like constructions like the on me construction, like my plants all died on me, which indicates regret or feeling badly about something. We have things like closed class forms like lest, which indicate concern, like we should clear the floor lest he trip, means for concern for his tripping. There is affect like surprise or amazement, like it's so vivid. So meaning expressing a kind of affect. But that's it. It's sporadic, it's occasional. None of it seems to form into some kind of system. By contrast with, let's say, languages with prepositions, like English, which together form a whole system for marking distinctions of paths with respect to reference objects. Or like the modals in English, which is a whole system that subdivides force dynamics. Nothing represents a system, it constitutes a system in any language that I've ever encountered that represents a distinctional system for affect. Again, I encourage adopting the Martian perspective and so trying to invent what such a system, what would it look like if you had it. Well, so I invented such a system. So let's say you've got a parent and a child, and they live on the 10th floor. And here's an open window. The child is standing near the open window. Now the parent cognitively has a cognitive complex consisting of both of spatial knowledge and emotional knowledge. The emotional knowledge is anxiety and concern and fear for the child's safety. The spatial knowledge is that the child should move away from the window. Well, within this total cognitive complex, which portion is expressed within the closed class form of language? Well, it's the spatial. So English will say, get away from the window. The parent might say, get away from the window. There is no emotional form, closed class form, which I invented here, which is something like, act a fear the window. I made up a word, a fear. It should be a closed class form, which should be one element within a system of affect. Nothing like that exists in English. Comparably, let's say in the same room, one wall is freshly painted, and now the child is near the freshly painted wall. The parent is now worried that the child is going to put his hands on the paint and ruin the paint. So now the parent is concerned about the paint job, not about the child, and wants the child to be nice to the paint job, to act in favor of the paint job. And again, there's a spatial component, which is the child should move away, and there's an affective component of concern for or desire for being nice to towards the paint. Well, again, out of this total cognitive complex, which elements are abstracted away for closed class representation? Again, it's going to be spatial. Again, the parent will say, get away from the wall. The same expression, get away from. And there will be no counterpart closed class form representing, again, I made up one, I invented one, act a favor of the wall. There's no such thing. So I tried to start out mapping a system of affective things, a fear, a favor, who knows what else. But nothing like that exists. So for some strange reason, the language seems to have drawn very little of any kind of structure or character from the affect system. One possible explanation is that the paralanguage systems, such as facial expressions, body language, maybe gestures, I don't know, independently were present all along in hominids, in primates, and may have been a system already so capable of conveying emotional states that language didn't bother to replicate this in its structural system. Who knows? But in any case, it seems to be the case. Okay, third comparison is between language and culture. Well, it's getting late. I think I'll make this maybe my last comparison. Okay, so language and culture. And you could compare, so again, I proposed the existence of a portion of cognition, a system within cognition which is dedicated to picking up on cultural patterns and manifesting them. It's orchestrating our cultural, structural behavior. Okay, so there's two ways to compare it. One is cross-linguistically as compared to cross-culturally. So let's do that first. George Murdoch was an anthropologist who built up a list of some 73 features that, in his at his time seemed to be universal. In all of the cultures that were studied at that time, all cultures had all of these features. They all had marriage ceremonies, they all had food preparation, they all had legal systems, they all had greetings, and so forth. They all had status differentiation. There's 73 of these there. You'd think that there might be something within this list of 73, at least some large proportion of them might be structural in character within the culture system. And maybe that's the case. Not simply a coincidence due to commonalities of how humans live their lives, but actually structural, somehow wired into the anthropological system, to the cultural system. Well, of all of those 73, at most that I could find were 8 linguistic closed class types that seemed to correspond at all to any of those 73. And of those, only 3 or 4 had any extensive closed class representation or specialness. Like one of the main ones would be status differentiation, which seems to run through all cultures. And there is a lot of closed class representation of status difference in language. For example, the pronouns in some South American Spanish, they make 3 distinctions: vos, tú, and usted, for most familiar, semi-familiar, formal, that kind of thing. All right. So, and there's also for etiquette, courtesy. So there are things in language that indicate politeness. So, for example, instead of saying that, for example, English has a way of making it polite, could you please speak up, versus the imperative, speak up. So that's politeness. And then you can, instead of directing someone to do something, you can suggest it as a courtesy. So you can say, why don't you go abroad? It's a suggestion. Instead of, you should go abroad, that's an urging. So this distinction of courtesy, etiquette, politeness seems to cross cultural bond between cultural structuring and linguistic structuring. But very little else. So there's rather minimal overlap. Let me take an example, switch down to comparing just an individual culture and an individual language. That's single culture with single language. That's page 136. And this is a former colleague of mine, David Wilkins, who worked on a language called Barntwe Arnda, something like that. It's it's Australian Aboriginal language, and this language has several overlaps between its own closed class forms and its culture. For example, that culture, as generally in Australia, is enormously concerned with kinship relationships, with many different distinctions. Well, it turns out that some of that shows up in its pronouns. So for any of the plural, dual or plural pronouns, first, second, and third person, there isn't just one plural pronoun for we, there's 3, depending on the following things. A distinction. If there are people within our group of 3 that, or more, that belong to separate patrimoieties, I don't even know what a patrimoiety is, but it's some kind of kinship distinction. That's one pronoun. You'd use a different pronoun if they belong to the same patrimoiety, but were of different generations. And a third pronoun if they belong to the same patrimoiety, but were of the same generation. So here's a beautiful example of where culture and language intertwine. But there's very little else. in fact, I took the opposite perspective on this from David Wilkins. He looked for these examples to show how much penetration into language there was from culture, but I turned it on its head. In fact, these are his best examples. He's got, 2 best examples, and everything else starts looking like grammatical distinctions that are made in many other languages with vastly different cultures. So it seems like and again, surprisingly, the structural delineations within culture are not much in overlap with those of the closed class systems of language. And I can, taking this perspective allows me to show how Benjamin Whorf, how the Whorf hypothesis fits in here. The Whorf hypothesis, or at least one of them, has to be seen in the following perspective. Of all the cognitive systems, only 2 have the following property, and those 2 are language and culture. They have the following property, namely, each of them has one portion which is universal, so it's the universal grammar or universals of culture, which are true across all humans, and another portion which is locally changeable. Hence, you've got different particular languages, different particular cultures. This is not true with visual perception. You do not have local variations of visual perception. It's all universal. You do not have local variations of motor control. There are a few things that change from culture to culture in how you move your body, but for the most part, it's the same universal system. So only language and culture have this bipartite kind of distinction between universal and particular. And the Whorf hypothesis simply says that in any given local place, the particular aspects of the language system of that locality correlates with the particular portion, the particularistic portion of the culture of that locality. So that's what the Whorf hypothesis restated in this new perspective means. That's all it means. The Whorf hypothesis doesn't even apply to the first thing I gave about George, the Murdoch list, and it certainly doesn't apply to any of the other comparisons. So one nice thing about this framework of comparing cognitive systems is it allows you to place other research endeavors into a larger framework. Let me just give you one taste of this next section. The next section is overlaps between the understanding system and language. And in general, it seems to me that there is something in common between all of the following. The concepts expressed by the closed class system of languages around the world. There's something basic about these, all of the following. So the concepts expressed by the closed class system, the structure present in infants and children in any cognitive system, in their visual system, in their motor system, in their understanding system, the concepts or the concepts and structural aspects. I'm just going to refer to between language in the understanding system, not vision, but in early science, or let's say the traditional lore within various traditional cultures, within early science as opposed to developed science, and within casual science, when sophisticated scientists just talk casually and don't try. there's something in common across all of those, which is some kind of core conceptual structuring, conceptual organizing system. That's my proposal. And so, for example, as a child develops, let's say concepts of force. The first concepts of force that a child is able to entertain, to experience, to understand, are precisely the ones that show up in the closed class system of language. Later, as the child acquires more complicated force concepts, those can no longer, the closed class system of language kind of seals off gradually, and no further more complicated force concepts can make their way into the closed class system, and must instead, if they're going to be expressed by open class forms. And so there's a kind of like, my idea is that there's kind of like a core understanding system that's common to early childhood, the closed class system of language, early science, which is a kind of basic structural system. And so one example of that, in force dynamics, which is this discussion of force dynamics readily expresses certain very fundamental force relationships. So two forces opposing each other head-on is the most readily expressed in languages. And it may well be one of the force concepts that children most readily grasp. Also expressed in the closed class system of languages, but less so, is radial force imposition, compression down into a concentric kind of compression. For example, the Latin prefix con, C-O-N, as in confine, contain, I think one of its senses is to indicate force compression radially inward. Okay, and it may well be that that kind of force concept is within the infant's conceptual ability, as in squeezing something. Still less represented by closed class forms is forces that are in alignment. They show up in closed class forms like moreover, this principle, this buttresses it, and a few other places. But it's not very extensive. Maybe children have a small sense of forces in alignment. But not in closed class, not represented by closed class forms, are things like forces approaching each other at an angle, or three forces coming together at odd angles intersecting, or a force acting over an arc instead of straight. Those are all much more advanced concepts. And it may well be that as a child grows developmentally, more adult portions of its cognition are in fact able to absorb and handle those particular conceptualizations. But by then, the closed class system of language is kind of sealed off and can no longer, and it's sort of like there's maybe a formative stage, a sensitive phase in language acquisition, which permits the structural importation into its closed class system of certain other structural aspects of other cognitive systems. But if they arrive after a certain critical phase, they can no longer enter the closed class system. And that's why we don't find these additional concepts in the closed class system. If we find them anywhere, they're only in the lexical forms. So that's kind of like, I'll end here, but just to give a quick idea, a summary of what I've been doing. It's again a comparison across all the different cognitive systems, major and ultimately minor, there are minor cognitive systems such as music. I've undertaken several pairwise comparisons, language and one X and language and Y, for the most part. Ultimately, to see what is common across them, and in each case we found some things in common and some things that are not in common across these pairs. And ultimately, you'd want to then look over all of these systems together and see which structuring aspects run in common through all of them. As I suggested at the outset, maybe hierarchical embedding would be one of those. And those would have to be the most fundamental structuring aspects of cognition, I suppose. And if you pursue this kind of project, ultimately you'll wind up with something like what is structure, what is organizational in human cognition.